Thanks, Joseph. First thing Joseph asked when I brought up my slides is this a boy meets girl story? Because ArcGIS Pro Meets FME. They've been married for some years now. I wasn't even there when the wedding happened. It was something like 2004. I inherited managing the extension some 8 or 9 years ago. So here we are today. I've made a stealth enhancement to my slides, which I hope comes up. Here it goes. Just on this side of things. No, it's not going there. I'll have to do this. Hang on. That's the other thing you need to watch. I'll get rid of that. And hopefully things are going to work. So my stealth enhancement to the slides is this thing here, which is a rocket launch from New Zealand, which happened yesterday. Amazing timing talking to Chris Hadfield at the show here. I have an 8-year-old space buff. I'm meeting an astronaut. My home country has its first orbital launch on the pad, ready to go, and it went off without clockwork. And Chris Hadfield asked me to pass on his congratulations to the CEO of the rocket company, whose cell phone number I happen to have because he was invited to speak at the FME conference. So I managed to close the loop with my little 8-year-old, a famous astronaut, and a rocket company doing great things. It's all because of FME. So we're playing the long game here, like Dale said. Stick with it, and eventually amazing things will happen. Okay, that's not my day job, so let's go back to what I'm supposed to talk about, which is this stuff here. ArcGIS Pro Meets FME. Let's carry on with that. Okay, so that's what I do, Data Interop Product Manager. It is FME, safe, build it for us, we integrate it, and we ship it. I'm going to show you us doing extra things with it, some dog fooding, some samples that I ship out. I also look after geocoding, so some of the stuff I'm going to show you as examples is geocoding based, in fact all of it is, and also geoprocessing. So this is where I dabble in Python, which you'll see a little bit of too. I'm showing my age here, but some of you hear Don Murray say from time to time, is data is fundamentally evil. It's like English cars. I'm old enough to have worked on a few of them, and they're really, really bad. Made by idiots for geniuses to work on. Now, there's another little philosophical point I want to make here, that my inverse relation premise, some of the best data hides in the ugliest places. I'm going to show you a couple of examples which we download and we deal with it. Okay. Now, geocoding is something I love to do as well as my ETL work, because addresses have high value. A lot of customers have millions and millions of addresses. They drive their business workflows, and they're hard to put on a map. So you turn an address into a coordinate, you're doing very well. So a little primer here is one way of doing geocoding is to look for things inside the address data going in. Combinations of tokens are recognized. But the end game here is we need very structured data to be able to do this recognition. So we have to make this structured data. We call it reference data. So to find these things in this mess of stuff going in to do geocoding, you need this stuff. So here's a couple of jurisdictions where I'll be showing some work I've done, Australia and New Zealand. You can see these are like identifier dialogues from ArcGIS Pro. I've clicked on a point feature. You see there's highly granular attribution there. Parts of addresses are there, like apartment numbers, street names, street types, and so forth. So the good news is, in those jurisdictions where I want to give people a leg up, Australia and New Zealand, and this happens around the world, we have good data here. It's rooftop data, so it's high precision. Sub-addresses are there, so you've got apartments and flats and all this other stuff. It's authoritative, it's free, it's curated. You can just download it. The bad news is it can be 6 gigabytes of CSV data, or it's an ISO 19160 construction, which is a self-join on millions of rows. That's the bad news. So to pick one example, GNAF in Australia, it's an acronym well known to some of my usual suspect friends in the audience here. That one here is the 6 gigabyte payload, 162 data files and 50 lookup table files. How do we deal with that? So I'm going to show you kind of a semi-dynamic workflow. I could have made it dynamic, but the point of my sample I'm going to show you is I want to make it simple for users to go and run with themselves. Nothing too fancy. Okay, so let's go to a demo, and I hope this works. We're getting there. Here is ArcGIS Pro. So this is the end game here. I've made this reference data, and I'll identify a feature. So here you go. You can see the nice stuff I need to build my geocoding tools with the other stuff that we ship, and it's all done. It's all done and dusted. But what came in is this stuff here. One zip file, which if I cracked it open, I can dig down and I can see the stuff that's in there. Hundreds and hundreds of CSV files happen to have a different extension. But that's what we've got. If you study the documentation, you can see that it's got some kind of logical schema, but you're dealing with giant text files, and they're split by state, by geography, and they're just this giant mess. However, FME to the rescue. I open my analysis tab here, and you see I have Workbench available. So this is FME. The developer's standing at the back there. He's going to hope this works like I do. And we're good to go. So you and I in the audience, this will not be rocket science for you, even though I started with rocketry. This will be FME. So I made some workbenches here. So I could have used, in fact I may have, I can't remember, FME itself, or I could have just started this work in Pro and done this in an ad hoc workflow. So zooming in here, familiar workbench environment. I use a zip extractor, which I downloaded off FME Hub that works as advertised, a couple of feature readers. I mess with an attribute which I use to split the data into tables going out, and I make the dozens of tables which are available in the download here. Now, do not panic that you see, say, this thing here looks like missing connections to attributes. At runtime, they connect, because everything comes through from one FME feature type. I just fan it out to where I know it's going to go. So this is one workbench I managed to use to pull all that 6 gigabytes of data into useful tables. Nothing for my customers, my users, to worry about. So go over here, the project pane. If I look in the databases there, it all goes in there. So there's like 15, 17 million features I don't recall. It takes 9 hours, but that's okay. You let it run overnight and you go out and have a few drinks or have a meal, whatever, come back the next day. In my case, I'm paid by the hour, so I'd sit and watch it. But users do nothing at all. So you saw me opened up Workbench there. I don't have to open it up that way. I could have, and I won't right now. Got real estate trouble here, sorry. Go on, back to the project. Used the tools I just showed you as Esri geoprocessing tools. So this one here is the only other step I would really need to do to turn those tables into actual geometry with the attribution collected together. And very simple when it gets there. This could be faster to open, Curtis. It's the developer at the back. It's easy to ping the poor guy. Okay, this comes up. It's just Workbench. It looks like an Esri geoprocessing tool with a funky icon, but it's also FME. So all I'm doing really here in this data, one of the tables I made back there in the previous step, I mess with it a little bit to do things like clone features that have address ranges into new copies of features, a couple of other little things, and that's my reference data, which goes into making my geocoding locator, which I can use interactively here. So in the case of, say, a country like Australia, and I'll show you New Zealand shortly, I turned that mess of CSV data into high-value data product. And I'm not going to show you batch geocoding, but I'll type in that address, for example, and it goes to wherever it was I clicked, so it's there. So people can get their business processes on the map through a couple of simple workspaces and a little bit of a download, a little bit of a wait for processing, and you're done. So in that example, I bundled up the stuff I did, and I shared it out on ArcGIS Online as a sample. There's 170 downloads. Remember, that's 170 organizations who are leveraging the national data on a quarterly basis and getting lots and lots of value from relatively little work. And we don't get to charge for it. My boss was really mad. Not really. They appreciate that. So a related one here, you didn't learn anything at all about any FME-related tricks in that last little sample. I don't have a lot more I can show because this isn't really challenging ETL. One example here is the equivalent workflow I put together for New Zealand. I'll slow down a bit because we have plenty of time, right? Same idea, I'm going to make some reference data, but what I have going in is a table here. There's only a couple of million localities in New Zealand with addresses, but I've got a table here of 9.7 million features. What's going on there? The ISO, in their wisdom, and I mustn't really bag them because I know they do put a lot of work in these things, have come up with an addressing standard where all the components of addresses are split out. That's nice because we're going to need them later. but they all go into one table. They're keyed on an address ID, this guy here, but you see I'm going to address number elements, I get to road names, and they mix and match. There's no order in this table at all. So this indicates to me, and it gets scary for me, I'm going to need a table pivot on a 10 million row table. And my brain hurts when I think about table pivots because I'm not a DBA. I have to go back to the documentation every time. But I'm also lazy, so I thought, how can I do this in FME and get it right? So the trick is, let me see. Go back to my project here. I have this guy here. I'll open it up. And at all times try and obey Don Murray's 10 transformer rule for a workbench. I cheat, I use Python, but not in this one. All I had, that's not the right one. Come back here. Sorry, this guy here, finger trouble. Have to sit through another launch here. But that 10-ish million row table going in, if I read it in order of the address ID key and also order of address component, all I have to do is these things here and output it as a properly split table that has been pivoted. So I just do the pivot of the names here, and aggregate here does the merging of the set of rows, 5 or 6, whatever it happens to be for any particular address, pulls their components together, and everything just drops right out. So this takes, in the case of 10 million rows, some time, a couple of hours maybe, I don't recall, but the job's essentially done. The only other thing is, one thing that was a little bit trickier to do, but was necessary, is what you're about to see. Again, the jurisdiction implied address ranges in various ways, particularly sub-addresses, like address 1A to 12D, it will go 1 ABCD, 2 ABCD, up to 12 ABCD. Is that, say, a retirement village, or wherever it happens to be? That's kind of implied ranges. I pulled out my Python skills and used regular expression checks to see if ranges of numbers were implied, and then you just got to put together some code. This will be one of the more scary ones for lists and characters, for more characters, output an extra feature per case. So your Python caller, and this was a learning experience for me by doing, your Python caller can output more features than it gets in it, which was nice. So I found 20, 30, 40,000 extra addresses just by doing that, and it needed to be done because they're real addresses. Not much else is happening here that would teach you much. I'm just making reference data. And again, I can use Locator there. First time it hydrates, it takes a little bit to get the stuff into memory. Did it work? Yeah, there it is. So my neck of the woods, close to where I used to live. And if I go here, I could do forward geocoding, back to wherever that was. So that works. I closed things off end to end. I'm also able to develop custom locator styles. It's some more added value for the customers. And again, ship that out as a sample to my compatriots. So that's 2 jurisdictions with some couple of days work probably. I managed to switch the lights on pretty well in a couple of whole economies. So this is, I think, it makes me feel good to be able to close the loop with my skills with FME, with geocoding, and some know-how about where data comes from, and really leverage things for our customers, which is my job. Other dog fooding we do, and I can't show you the results, but I can talk it through, is stuff like this guy here. And this was a stretch for me because I have hardly ever use custom transformers or make them, but I had to here. So here's an alarming thing for everyone in our office. It's an ArcGIS Pro project with no maps or tables. It's got nothing. What's it got? Okay, over here it has some toolboxes. It's the ideas toolbox. And it's that time of year when we get concerned about what we've got to do during our user conference, and we do some research on all the data flow we have coming through from our CRM and all the rest of it. And I put together some ETL tools that will handle this non-spatial data and make summary reports from it. So this one here happens to be our ideas website, Esri's ideas website. So Safe Software run Answer Hub. You can go there now and you can look at what's there, see how it's ranking and all the rest. We have exactly the equivalent thing for Esri. This workspace calls the REST endpoint for the technology we use. It does it in a loop of 100 records at a time, harvests the whole lot, unpicks the JSON and writes out an Excel spreadsheet with counts, ranks, hyperlinks, all the data we need to give to managers. All they ever want, all they can eat. And it can run it every 5 minutes. So that is completely non-spatial, purely business-oriented data mining work I did with FME technology in the office because that was just simply the smartest way to do it with my know-how. I'm approaching the 20 minutes that we had before the 10 minutes of questions. There's another one here which is the same idea, some business content was going on. Now, we recently, with the help of the good people from SAFE, made sure that the Python environments in ArcGIS Pro 2 and FME that ships as the FME product and in Data Interop are coherent, so you can call ArcPy safely without having to monkey with path files and environment variables yourself. So that we made that as a SJW, or should just work, and does, at least in my machine. And I was bravely launching down the path of calling FME objects from within standalone Esri Python script tools, and it sometimes works, but it's fragile. So we're kind of leaning towards making the decision of not really recommending it, supporting it. I love the concept of the change detector in Workbench. I made my own, which uses FME objects hash calculation function to do the same dictionary diff test that you see in change detector in Workbench. My code here is crazy fast, but every time something happens with Python, it breaks. So while this is public now, you can download it, and I have 130 odd, possibly slightly frustrated customers. I may pull it because I don't know that we can support this, but I kind of do crazy things to stretch myself and see what we can find value and where we can find it. And some of them work, some of them don't. So there you go. Our content team uses FME and or Data Interop. I actually haven't checked to build a lot of the material, the data we use to drive our web maps and other things. As I showed you, Geocoding team, I will prototype something for them. They'll prove it. They may, because of the skills of the people involved, move things on towards pure Python or something like that. But I show them what I want in the product, what I want them to ship, and I do it myself. And that just cuts out a whole lot of talk and reports and all the rest of it. So there are a few examples of how and when we use FME technology in Esri. We have a bunch of FME licenses for things like the content work and R&D work. And we have our own Data Interop product, which there are a couple of us work on pretty much full time. And like I say, you get to meet astronauts and have happy kids. It's great. So that's all the material I have. I'm happy to take questions, and we're making good time here. Oh, yes?
What reader do you use for the ISO 19620 standard?
Can you repeat that, please?
What reader do you use to read the ISO standard?
ISO standards? That question is, what reader do we use to read?
The ISO.
Like I showed you, the jurisdiction supports download of file geodatabase. So they have just put the data into the schema in file geodatabase, and it's an easy read here. I flick between using the API reader and the ArcObjects reader. The API reader lets you choose some options, the other one doesn't. Again.
Where's the XY stored? Is it stored within the object in the text files?
In the case of the Australian data, it was what we call an event table. So the question was, where's the XY data coming from? It was X and Y, well, latitude and longitude attributes, which of course are simple to make into geometry. In the case of the New Zealand data, it was spatially enabled data in the first place. So it was a feature class, but without various joins and things that you need. Again.
What happens when you hit an address without a spatial
Yes, that's the island of lost geometry, Null Island. There was an article in the paper not too long ago. The question was, what happens if you have no geometry in reference data? That is allowed, it just will never get onto a map. So there are cases where you have addresses you might want to parse into components, but never locate. I can't think of one now, but that's how that would work. It would possibly frustrate users if they knew about it, but it would function. All right. So I know I have at least one annoyed business partner. He's been very quiet. This is his line of work too. But it's also my day job, and I'm enjoying every minute of it. Hey, well, I guess we finished in record time. More questions? Oh, here we go. No, sorry, I didn't give you the 30,000-foot view. I'm making here reference data, which we then ingest and cook into an index structure we call a locator. And in Esri technology, we can do that on the desktop and use it locally, or we can publish it as a service. It's just some files, a handful of files, which are some names and pointers and the index structure. It's quite big business for us and good differentiating technology. I know there's lots of the Geocoder Transformer and ArcGIS Online Geocoder and so forth in Workbench, but not everybody has that technology. We ship our locator and geocoding technology right across our platform, desktop engine, mobile server, and all the index structures work the same in all of them. Yes, the business reason is users want to make their own locators, and they do with like their asset data or whatever it happens to be. In the case of these whole jurisdictions, there's not many people that have the know-how to plug everything together, so I threw out samples so our friends in Australia and in New Zealand will be able to get on with their day jobs and leverage this lovely free data without ever having to worry about building everything. So, and they know me, and they know if they get in touch with me and they have a problem, I'll somehow or other get it fixed. It's very difficult for a whole community to organise themselves around anything new and get it done in a timely fashion. So it's, work is fun. Work is fun. So there we go. Thank you very much.